So when we want to prove this principle of moments in the lab, what we have set up is a meter stick, and it is suspended and attached to a retort stand to accommodate the pivot. And then what we do is we add a force, okay? So this would be our force. And normally in the lab, we would have the little slotted weights or the masses suspended on the meter stick. Okay, so usually 100 grams. Okay. Now, this is just an example of a question an example of values that we would have got. So we have our pivot and we have a distance, our mass is 0.5 meters away. And on the other side, our mass is 0.3 meters away. So we want to prove if that is balanced or not, okay? So we have our mass on this side, and then we would have a little mass here as well, okay? So here we have on this side, and it's already given to you, we have 6 newtons of a force. So we have 6 newtons and a distance of 0.5 meters. And here we don't know, on the other side, we don't know what the mass is, but we do know that the distance is 0.3. And we want to make the meter stick balanced, or they're saying here already the meter stick is balanced. So how can you prove that? Using the principle of moments, and we just have to make a few calculations here. So the principle of moments is just stated on the other page, is that we must have the anti-clockwise is equal to the clockwise movement, okay? In other words, your clockwise movement is going in this direction, your anti-clockwise is going in the opposite direction. So we'll work out the anti-clockwise moment first because we've been given the values for that. So force times distance is our moments formula. So our force was given to us as 6 newtons and the distance was 0.5. So if we multiply those values out, we are given 3. Now on the other side here, if you just check, we have been given 3 as our distance, but we don't know the mass or the force, okay? So this is what we need to work out. So our force here, we have to work out, but we know that our distance is 0.3 because that was the distance from the pivot. Now we just need to do a wee bit of cross multiplication here. We know that the 3 is what our moment is on the anti-clockwise. We're trying to find the moment on the clockwise side, okay? So we want to get F, or the force, on its own. How do we do that? Well, if we have F as a force on its own, then we want to bring over this 0.3. So if it's multiplying on this side, it must be dividing on the other side. So we have 3, which is our value already, and we're going to divide that by 0.3. And that will give us our term of F. When we slot that into the calculator, we get a value of 10 as the force. So the force equals 10 newtons. So if we just go back to the top of the page here, in order for this particular meter stick to be balanced, if you have a force of 6 newtons on this side, well then to balance it you must have a force of 10 newtons on the other side for it to be balanced. The difference being here that the closer you are to the pivot, then you need a greater force. And that's true because we're closer to the pivot here, but we need a greater force of 10 newtons. The further we are from the pivot, we need a lower force, okay? So that's the greater force because you're closer to the pivot. And the video can explain that to you.